All right, so today we're doing section 9.9. We're not going to spend a whole lot of time on this one. So here we're going to begin representing functions by power series. So consider the function f of x equals 1 over 1 minus x. Hopefully you immediately go, that kind of looks like a over 1 minus r, which some of you remember is the sum of the terms of a geometric series provided the absolute value of r is less than 1.
Yeah.
Some of you don't, to your dismay and mine.
That's the easiest question on the test.
So if we let a be equal to 1 and r be equal to x, then this function, 1 over 1 minus x, is equal to the summation as n goes from 0 to infinity of x to the n, which is 1 plus x squared plus x cubed, yada, 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 provided that the absolute value of x is less than 1, because for a geometric series to converge, the absolute value of r is less than 1. So we've replaced this fractional function with, it's called a rational function, by the way, in case you've forgotten that term, with a power series, and it's centered at 0. You can actually choose to center that at some other point if you want to, with differing intervals of convergence. So for example, let's say we wanted to obtain a power series for that original function, but we want it to be centered at -2. Why? I have no idea why you would want that.
Maybe.
But you could do it. So what you would have to do is rewrite this original function, 1 over 1 minus x, as 1 over 1 minus, we want it to be x plus 2, so that that's centered at -2. And since we have subtracted 2, we must also add 2 to compensate for that fact, so that these two are actually equivalent to one another. Then grouping the like terms, we'd have 1 over 3 minus x plus 2. Remember that the format is a over 1 minus r. Therefore, in order to make this be a 1, we'd have to divide every term by 3. And we would get 1/3 over 1 minus x plus 2 over 3. So a is 1/3 and r is x plus 2 over 3, provided that the absolute value of x plus 2 over 3 is less than 1. So 1 over 1 minus x is also equal to this series, the summation as n goes from 0 to infinity, of 1/3 times x plus 2 over 3 to the nth power, provided that the absolute value of x plus 2 over 3 is less than 1, which means the absolute value of x plus 2 has to be less than 3. That gives you that this is centered at -2 with a radius of 3. So we go 3 to either side of -2, and we're at -5 and at 1. We don't need to check the endpoints on this, because in a geometric series, if the absolute value of r is equal to 1, the series diverges. Okay, so let's practice changing some of these. You don't see these as often on the AP exam as you once did. I'll just be completely honest with you. But it's something that pops up now and then. So we'll start with 4 over x plus 2. We want this to be centered at 0. So I'll put it as 4 over 2. And it's supposed to be, well, we'll deal with that in just a second. So I've really done nothing at this point, right? Other than make it pretty obvious that it's centered at 0. It's supposed to be a over 1 minus r, right?
Yeah.
Okay. So this would be 4 over 2 minus 0 minus x. Still centered at 0, but it's supposed to be a over 1 minus r, so I need to divide everybody by 2. So this would be 2 over 1 minus 0 minus x over 2. So 4 over x plus 2 is equal to the summation as n goes from 0 to infinity. I want the first term to be 2, so I'll just do 2 times, and let's simplify this. Let's make that the 0 minus x over 2. Let's just make that negative x over 2 to the nth power. So the first term is 2, and then every time we add on another term, we're going to multiply by negative x over 2. Now, this is centered at 0, so the absolute value of negative x over 2 has to be less than 1. This is sometimes called a geometric power series because we've made it geometric. Multiplying by 2, we get the absolute value of the opposite of x has to be less than 2. So it would be negative x is less than, negative 2 is less than x is less than 2 is our interval of convergence. Okay? It's mostly just messing with this to where it looks like what you want it to look like. Let's do another one like that. Find a power series for f of x equals 1 over x, centered at 1. Okie dokie. So we'll start with the original, 1 over x. So I want to have an x minus 1, right? So at that point, what have I done to the denominator? I've subtracted 1. So I need to add 1 to compensate for that. So then, I want it to be a over 1 minus r. How am I going to do that? So it'd be 1 over 1 minus 1 minus x, right? So now it's in the right form, a over 1 minus r. So that's going to be the summation as n goes from 0 to infinity of, the first term is just going to be 1 times 1 minus x to the nth power. By the way, I could rewrite this as the summation as n goes from 0 to infinity of negative 1 to the nth times x minus 1 to the nth. Does that make sense that I could rewrite it like that? I just had factored a negative 1 to the nth out. And then I know this is centered at 1 and has a radius of 1, so this is going to be what? 0 is less than x is less than 1? Oh, sorry, it's less than 2. Because it's centered at 1 and has a radius of 1. Okay, any questions about that? So that's just an exercise in what I call algebraic manipulation. You just mess with it to make it what you want. So this does come up fairly often, not every year, but fairly often. Since a power series is like an infinite polynomial, we can do a lot of the same things that you can do with a polynomial. You can add, you can subtract, you can multiply by a constant. You can multiply a whole series together, and that one comes up now and then, and it's awful. And even differentiate and integrate. So, let's take a look at this one. Find a power series for f of x is equal to 3x minus 1 over x squared minus 1, which is also equal to 2 over x plus 1 plus 1 over x minus 1. Okay? So, we know that 3x minus 1 over x squared minus 1 is equal to 2 over x plus 1 plus 1 over x minus 1. By the way, how do you think they got that? If I just gave you the first one, how could you get those two fractions?
Partial fraction.
Yeah.
Partial fractions, exactly right. You'd have to use the method of partial fractions to split it up. And both of these, I'd like them to be a over 1 minus r. And you're like, okay. So I'll make this 2 over 1 minus negative x. Hello. And this one, I'll make it 1 over, oh, you know what? Let's just multiply top and bottom by negative 1, because then I'd have negative 1 over 1 minus x. So I've got two different expressions that I can write both of them as series. And since it has the same starting value, starts at 0, goes to infinity, I can just add them together. So this would be the summation as n goes from 0 to infinity. For this first one, it'd be 2 times negative x to the nth, plus for the second one, it would be negative 1 times x to the nth. And you really do need to put some sort of parentheticals of some kind, either parentheses or brackets or something, because otherwise it's not clear where you want to stop doing the summation. We would also like to be able to see if we can simplify this at least some. Notice both of them have an x to the nth in them. So you'll frequently see these rewritten, especially on multiple choice questions, as here I'm going to factor out a negative 1 to the nth, so that'll be 2 times negative 1 to the nth. Here, factoring out the x to the n, I just have a minus 1 times x to the nth. And you don't really need parentheses of any kind at that point. I frequently stick them on just to make it clear I want all that to be part of my series. So this is some sort of, I don't know, 2 times negative 1 to the nth minus 1. That might be simplifiable. I don't know what it would be.
Maybe.
If now I have to look. So if n is 0, that's going to be 2 minus 1 is 1. If n is 1, that's going to be negative 2 minus 1 is negative 3. If n is 2, oh, so it's alternating, but it's alternating in a really weird fashion.
Indeed.
Yeah, we'll just leave it. So, here's an interesting question. Use the result of our second example, and I'm giving you the result here, that 1 over x is equal to the summation as n goes from 0 to infinity of negative 1 to the nth times x minus 1 to the nth on the interval from 0 to 2. Are you checking to see if that's what we really had?
No, I mean, how can we find x from 0 to 2?
Because this was centered at 1 and it had a radius of 1, so it was from 0 to 2. Did we not write that on the second example? Yeah, please add that on the interval from 0 to 2 on this example, exclusive of the endpoints. Pardon?
I wrote that. Oh, I thought we were talking about the one we had just done.
No, the second example. So example 1, example 2, this one.
Got it.
Yeah, I thought the one we just
You just got Cecil'd.
Aha.
First time ever. All right. So to find a power series for natural log of x centered at 1.
Interesting.
Well, what do we have to do to 1 over x to get natural log of x?
Integral.
Yeah, so this will be natural log of x is going to be the integral for 1 over x dx. So this is going to be some constant plus the summation as n goes from 0 to infinity. Remember, when we do an integral, we don't lose any terms. In fact, as we add a constant of, well, the negative 1 to the nth has nothing to do with the x, so it just stays. Here, we will add 1 to the power. So it's x minus 1 to the n plus 1 divided by the new power, n plus 1. Now, the question becomes, well, what is the value of c? Well, what is an easy natural log thing to know? There are two. Natural log of something and natural log of something else are both really easy. What are they?
1.
Natural log of 1 is 0, and natural log of 0 doesn't exist. That's not the other one. E is the other one. Which one do we want to use on this one? We want to use 1.
Okay.
So if we let x equal 1, we've got natural log of 1, which is 0, is equal to c plus, the summation as n goes from 0 to infinity of negative 1 to the nth times x minus, oh, that'll be 1 minus 1, won't it? Because we're letting x be equal to 1.
Zero. Interesting.
So the series, all the terms are 0. So that means c equals 0.
Now that makes it easy.
That does make it nicer. So the natural log of x is the summation as n goes from 0 to infinity of negative 1 to the nth, x minus 1 to the n plus 1 over n plus 1. And we really should check the domain for this. We know that this original function had a domain from 0 to 2, but it wasn't inclusive of either one. Can my integral be inclusive of those?
Yes.
Yeah. If it takes the derivative, it can't be inclusive of those, but if we take the antiderivative, it could. So if we let x be equal to 0, we've got the summation as n goes from 0 to infinity of negative 1 to the nth times negative 1 to the n plus 1 over n plus 1. What does that numerator simplify to? No? Yeah, just -1. Because one of these two is -1 and one of those two is +1 for all values of n. So that's going to be -1 over n plus 1. What do we know about this particular series?
It's gonna converge.
It's diverge. It's unconfirmed.
This one diverges. This is equal to the summation, or hang on a second, let's factor out the negative. -1 times the summation as n goes from 0 to infinity of 1 over n plus 1. What kind of a series is that fairly similar to? 1 over n, the harmonic series, which diverges. Now, is this bigger than that harmonic series? No, it's smaller. So can we do a direct comparison? Nope, we would have to do a limit comparison. So we're going to compare that to the summation as n goes from 0 to infinity of 1 over n. That's the divergent harmonic series. And we'll take the limit as n goes to infinity of 1 over n plus 1 over 1 over n. It really doesn't matter which one you put on top and which one you put on bottom, which would be the limit as n goes to infinity of n over n plus 1, which is 1. How is 1 important in this case?
Positive and finite.
It's positive and finite. Very good. Therefore, the summation as n goes from 0 to infinity of -1 over the n plus 1 also diverges. Now, we should have known it diverged without doing any work at all. How do we know that this is going to diverge? Nope.
Is that A2?
Pardon?
It's different than 0. Is that A2? I don't know.
What are we trying to estimate? And actually, we're not even estimate, find.
Natural law.
What's natural log of 0? It doesn't exist. So my series had better not converge at 0.
Yeah.
All right, and in the interest of time, if we were to substitute in x is equal to 2 here, we would have 1 over n plus 1 again. It would be an alternating series this time. It would converge. So, comma, 0 less than x less than or equal to 2. We kind of did it in our heads, but
We're just that good. We don't need to show our work.
all right. Oh, out of time. Sorry.
Look at that.
I will just say on this one, for arctangent, you're going to start with 1 over 1 plus x squared.
Yeah.
Let's finish that.
Can we finish?
No. Get out of here. We don't want you.
I'm pretty sure I got that one out of your book, so feel free to look there.